protocols, you may notice I'm wearing a slightly different outfit from yesterday, meaning it is a day later, so I hadn't had a chance to finish up my videos until now, but now I'm going to go ahead and finish these up. Hopefully you guys get a chance to see this and maybe watch them before class tonight. I know not everybody's going to be able to, but they should all be up before class tonight. So let's talk about the application layer. Okay, so the application layer is the layer that we focus on the most in this chapter. We're going to look at a lot of different protocols, but at the application layer, that's where a lot of functions happen in networking. So access by applications to network resources is, I think, our most obvious function. So when it mentions access by applications to network resources, we're talking applications like a web browser accessing the resources of a web page. Okay, that's just one example. There's a lot, and we'll go through some of those, but that's just one sampling of what you're dealing with. So with application layer protocols, obviously there's going to be a client and a client version and a server version of that software. So in the case of accessing a web page, your client would be your browser. That's the application on the client end, and then whatever host you're using to host the web server is going to be the application layer protocol, or the application layer software on the server end. Okay, and there's a lot of different softwares for that. We don't really go over the server end too much. We go mostly over the client end, at least as far as examples are concerned. You also have client and server data access. Of course, that's sort of the basic description of most network communications, is a client requesting resources from a server. Okay, that's really the description that comes down to. Okay, and then name resolution happens at this layer. We'll talk about that in more detail. Dynamic address assignment, again, more detail later. Authentication, user login. To access certain network resources requires authentication, meaning, a username and possibly a password. And data formatting and translation happens at this layer. We're not going to look at that in too much detail now. We'll look at that more in Chapter 7. But data formatting and translation happens at this layer. Okay, so we mentioned the protocol HTTP. We've mentioned this a couple of times now. This is, of course, the protocol used by the World Wide Web in general. It was originally developed to transfer HTML pages, web pages between devices, so between a web browser and a web server. Okay, but it's expanded to do other things, and it's mostly just changed versions. So increased versions have come out later, newer versions have come out of HTTP. It does the same thing, it just transfers data from point A to point B. So Hypertext Transfer Protocol is what it stands for, HTTP. Again, it's become sort of the protocol of the World Wide Web. Every website is using HTTP, and actually there's an additional version that is being utilized more and more by websites. It's called HTTPS. The S is for secure, and it works slightly differently, but basically the difference is encrypted or unencrypted data that's being transferred. So if it's got that S on there, it's using a type of encryption to send the data. Before it sends the data, it encrypts it first. So that's really all you need to know for now. I'm not going to delve into the differences there in too much detail. We'll talk about security to some degree, but you're going to need to know this later. Of course, TCP is the transport layer protocol that is utilized by HTTP. We're going to look at that when we look at transport layer later on, but just take note of that. TCP is the transport layer protocol that's used, and the default TCP port number, which again, we're going to look at this information, what this means later on, but you need to memorize these. HTTP uses TCP and port 80. Okay, so here's an example of an HTTP message. It just says essentially get HTTP 1.1 is the version, cengage.com. Okay, so it's requesting an HTML web page. The web page is cengage.com. Okay, so that's just one application layer protocol. Let's look at some more here. POP3, POP version 3, Post Office Protocol version 3. These are all email protocols. There's POP3, IMAP, and SMTP. These are application layer protocols that function for the purposes of sending and receiving emails. So that previous one would be utilized by a web browser. These would be utilized by email clients. So there's not a lot of good examples because a lot of people are using webmail more and more nowadays. And so really the only protocol that's being utilized, it's actually using HTTP because you're accessing your email from a web browser. But back in, in the past, I guess, in the long distant past of 2010, it was really common that you would use a program like Microsoft Office Outlook to access your emails. Nowadays, that confuses people too because Outlook.com is a thing. Okay, so don't get confused between the two. If you're using Outlook.com on an email or on a web browser, you navigate to Outlook.com. That's going to use HTTP for your email to be downloaded to your browser. But if you're using I don't know, I'm trying to think of some other ones besides Outlook so that I can avoid confusion. Thunderbird, Mozilla Thunderbird is a good example. That's one that maybe a few people will remember or recognize. But Thunderbird, it downloads the emails from a server. So there's two ways you can do that. So you can download the emails in their entirety using Post Office Protocol. Okay, POP uses TCP and port 110. And this would actually download incoming messages that come into the server, and it downloads them to your local desktop. It makes a copy of them, copies them from here, and puts them onto here. Now, there's a couple of different ways you can use POP. It depends on the client that you're using. You can either download it and leave a copy, or you can move it and delete the old copy. So that's those two ways. Either way, Post Office Protocol version 3 is what's being utilized. Okay, so that's taking email from a web server, an email server, and putting it onto your local desktop. Then you have IMAP version 4, Internet Message Access Protocol v4. This works a little differently. This is actually more commonly the protocol that would be used. So if you're using any kind of mail app that's a generic mail app, so for instance, I'll show you real quick. I use, on my phone, I use the default mail app, right? This is an iPhone. So I'm using the default mail app. We've got all of my inboxes. You see there's a number of inboxes here, right? There's 5 inboxes. But I'm able to check those on this device and on another device. Because I'm using IMAP to download to here, I can actually check those emails on another device and delete them off of that device, and it'll actually remove them off of here. IMAP gives you essentially, it doesn't download the entire message. It downloads just the subject header and who it's to, who it's from, all this information about your email. Rather than downloading the email in its entirety like POP3, it just downloads the header of the email, and then you can quickly look at it, and then if you delete it, it'll actually remove it. It does, rather than downloading, it's actually a better term to use would be synchronization. So it synchronizes the folders and anything that you do on your server across multiple clients. So you can check your email on, so if I go to gmail.com and check my email, that's using a web browser, and HTTP is how I'm actually viewing my emails. But now if I want to look at it on my phone, I can see the same thing on my phone as what I see on the browser, and that's because I'm using IMAP as my protocol for mail, for downloading mail. Now the final protocol is known as SMTP. SMTP is used in conjunction a lot with a program known as MIME, M-I-M-E. MIME is used for sending multimedia. I can't remember exactly what it stands for, but one of the letters is for multimedia. One of the M's is for multimedia. But anyways, if you send an email attachment, it would use MIME. But SMTP is the standard protocol, the main protocol that's used for sending email between one email server and another email server. Has nothing to do with getting it to you specifically. That would be handled by the email server itself. So if you download it with POP or download it with IMAP, that's one thing. But when an email goes from point A to point B, right, that's using SMTP. So if I have web server 1, let's do a little picture just to clarify. not web server, email server. And email server 2. And we want to send data between them. It uses SMTP. Okay? To clarify, email server 1 is sending a message to email server 2. Okay? Now, email server 2, let's say, in some way, you don't have to be directly connected, but let's say you have a connection somehow to your client. This is email, EMAIL, client. My spelling kind of got screwed up. But this is your email client, okay? It's connected up to server 2 somehow, right? It's not necessarily a direct, like a cable plugged into server 2. It's just connected logically, right, through IP addressing. We're not going to delve into that in too much detail, but it's connected to this server. This is hosting its email. Now, if it downloads email from the server, it's going to either use POP3 or IMAP. Okay? You see it's pulling from the server to the client. Okay? That's going to use POP3 or IMAP. So that's the difference between the protocols. SMTP is server to server. POP3 and IMAP are from server to client. Okay? Okay. I know there's going to be questions about that. I'm anticipating that. So you need to have a basic understanding of what these different protocols are and what they do. Just remember, POP3 downloads them. IMAP just shows you the header. SMTP is for sending from email to email, email server to email server. Okay? So when you send an email, you use SMTP. When you receive an email to a client, you either use POP3 or IMAP4. Okay? The other thing you need to remember is POP3 uses TCP port 110 and IMAP uses TCP port 143. And again, I mentioned with HTTP, there's a secure version and an insecure version. These are the insecure versions. There's secure versions of all three of these protocols. But we're not delving into that just now. Okay, FTP and TFTP, File Transfer Protocol and Trivial File Transfer Protocol. FTP is not really used on the internet anymore. It used to be very common on the internet, but it's not very secure. But it was used for basic device-to-device file transfer. Okay, and there's 2 ports used. One port is port 20 that would allow you to send control commands, like if I cut and paste a file from one folder to another on an FTP server, that's going to use port 20. Or if I copy and paste to my computer, that's going to use port 20. That just sending the commands. Now, actually transferring the files is happening on TCP port 21. Okay, so this uses 2 ports for full functionality. Okay, 20 and 21. Remember that. That's important. And they're both TCP. Okay. It's not secure, so it's not to be used over the internet, though it is still used in a lot of cases on LANs. We're going to talk about a protocol that's actually a lot more common than FTP, called SMB, in just a minute here. But the FTP is sort of an early networking program for transferring files. So if you just remember what it stands for, you should have an easy time remembering what it actually does. Again, not secure. Should not be used on the internet ever, because FTP doesn't have a secure version even. That's relatively true. There is a secure FTP that's available. It's called FTPS. There's also SFTP, but they're kind of funky programs that don't work exactly like FTP did, where the secure versions of the aforementioned ones work exactly the same. They just encrypt the data. So FTPS and SFTP are funky programs that you don't need to worry about too much. Then you have TFTP. TFTP has very little management capability. It's literally just for getting a file from point A to point B. So File Transfer Protocol has some management capabilities, meaning you can actually look at the file system, look at the arrangement of folders, and dig through and look at things. But with TFTP, you're just getting from point A to point B, and that's all it's concerned with. Okay, this is mostly used for like network boot for servers and switches, or not servers, but switches and routers and stuff like that. They would boot to an FTP server, or rather a TFTP server, so that they can load their operating system or their configuration, something like that. But don't get too hung up on that. It's just a simple protocol for transferring files. It's just getting from point A to point B. And this one uses UDP port 69. Keep that in mind. It's UDP and port 69. I think one of the port numbers in this is wrong. When I get to it, I'll take note of it, because I'm pretty sure one of the port numbers that's on the slides is wrong, and I will try and notate that, by the way, when we get to it. But so far, that's it. I'm sure people are going to have questions. If you have questions, I want you to ask me as soon as you come up with them. Make sure to write them down and bring them tonight. Okay, so I mentioned I'm going to talk about SMB. SMB is a far more common protocol for sharing files and printers on Windows networks. So also there is Linux and Mac OS support for SMB. They have their own variations. There's a Linux protocol called Samba, S-A-M-B-A, that's supposed to be very similar to SMB, and it's actually required to work with Windows, so you have to use that. And then Apple has AFS, Apple Files, no, is it AFS? AFP, Apple File Protocol. Don't worry about those. They're kind of hard to use, and in fact, SMB is more commonly used even with Apple applications. So, and even Linux applications. So keep that in mind. It's a good program for sharing resources on a network. So we've actually used this protocol. I don't know if you remember when we actually did our whole thing where we wrote // and then out server name and then / share name. So when you share a file in Windows, it's using SMB to do that. And SMB is typically not used over the internet, except in certain instances, but it uses TCP port 445. So you can set it up to share over the internet. I don't recommend it. It's not super secure, but there are certain instances where you can actually do configuration to allow SMB to be used over an internet connection. Okay. And then you have RDP, Remote Desktop Protocol. This is a very handy protocol. Essentially, it's used for accessing a Windows computer remotely using a Windows GUI. And so you can actually access the computer and make changes and use the mouse and use the keyboard. And it's like you're sitting at the computer itself when you use Remote Desktop Protocol to access a computer. It's used a lot for administration of workstations and servers remotely. You don't typically, again, this is one that you wouldn't use over the internet very often. There are some instances where you do. Again, I don't recommend it. It's not terribly secure. It uses port 3389, TCP and UDP, both TCP and UDP. UDP would be used for sending the screen back to you, and TCP is for establishing the connection. UDP is for sending back and forth data. TCP establishes the connection. We'll look at that in more detail, but it uses both TCP and UDP. Okay, Telnet and Secure Shell. These are used to access a command line interface. So if Remote Desktop is to access a GUI, these are the command line version. Telnet and Secure Shell would allow you to access a number of different command line interfaces over a network. So if you have a command line interface on like your switches or your routers, or even like Linux servers, you might have a command line server that you're running. You could use Telnet or SSH to access them. Okay, Telnet uses port 23. It's not secure. Sends password and clear text. It's definitely not to be used over the internet. I definitely highly recommend using anything other than Telnet over the internet. If you're on a local network and you're not super concerned about security between, my device and my router, for instance, then it's totally fine to use if you're very aware of your network. Larger corporate networks, I wouldn't use Telnet necessarily if you're not sure about who's on your network. But if you do know who's on your network and you're very sure about the security of your network internally, then Telnet's fine. SSH, however, provides an actual encrypted channel between the client and the server. So data that you send from using SSH, Secure Shell, for managing your switch or router or server or whatever, remotely is going to be encrypted. Okay, and this would be for sending command line commands. So, and then you have SNMP, Simple Network Management Protocol. SNMP works with an agent and a server. Software agents are installed on devices that you want to monitor. This is known as Simple Network Management Protocol. It's literally used to monitor and manage network devices, gather statistics about the network traffic. So typically you would install this on your switches, you would install an agent on your switches, your routers, and your PCs on a network, and they would all report information back to an SNMP server using this protocol. So your server would be what's actually collecting data, but your agents would be the client end, essentially sending data to your server. It operates on UDP ports 61 and 62. So there's a monitoring port and a management port, or really an analysis port. One port's sending data, and one port is actually allowing you to make changes and manage your software agents, essentially, in a nutshell. So that's SNMP. It's used a lot by, what's a good application that I could point to that uses SNMP? Network monitors like SolarWinds makes a lot of network monitors that use SNMP for a lot of their stuff. That's probably the only one I can really think of off the top of my head. If you have more questions about SNMP, you can always ask. If you think of something, if you have maybe even some experience and you've used this, please do inform the class tonight. Okay. So those are the main ones that we're just briefly looking at. Now we're going to look at two really important protocols that are at the application layer that are super important for network functionality. Number one is DHCP, and number two is DNS. Okay, so let's look first at DHCP. DHCP. So what is the point of DHCP? So a drawback of using TCP in a large network is keeping track of assigned addresses and to which machine they are assigned. So we've developed Dynamic Host Configuration Protocol. DHCP automatically assigns IP addresses as needed. So rather than you having to go to each device individually and set up an IP address on each device on a network, you can assign them automatically using a DHCP server. Okay, so when a device is turned on, when a server, a computer on a network, a client on a network is turned on, it's going to automatically request a DHCP, an IP address from a DHCP server. Okay, we're going to look at how this is done. It's very important. This is crucial. And then the server assigns an address for a specific amount of time. These addresses, or the amount of time, is known as a lease. So the lease has a timeout. It runs out after so many hours, minutes, days, whatever the case may be. Usually it's a matter of hours. So like 8 hours is pretty common. That's commonly what you see with a DHCP lease time. But once that expires, actually it's not quite when it expires, but usually it's so the computer is going to be keeping track of the lease time, and the server is going to be keeping track of the lease time. Both the client and the server are going to be keeping track of that information. And when the amount of time gets to a certain point, it's going to request a new lease, essentially. We'll look at that in just a minute here in a couple of slides. But that's DHCP in a nutshell. It's a server that's assigning IP address information to clients who request it for a given amount of time. Okay? And that's crucially important, because if you had to assign an IP address every time you joined a network, it'd be really inconvenient for using these guys. You connect up to Wi-Fi at Starbucks and you have to figure out what their IP addressing scheme is in order to connect. That'd be really annoying. So you don't have to do that though because of DHCP. So DHCP is composed of the following. So the DHCP server information is composed of the following. IP address scope, first and foremost. This is going to be the range of IP addresses that the server has leases that it can hand out. So the range is going to go from this IP address to this IP address. Okay, that's the scope. Okay, scope options include settings like default gateway, DNS servers, a domain name, and Win server and NetBIOS name. All these different options. The most commonly used ones are default gateway and DNS servers. Those are the most important to put in your scope options. You can also set a reservation. So if a particular MAC address on a network interface card, like so if my phone has a network interface card on it with a particular MAC address, if I set a reservation on a DHCP server and my phone attempts to get an IP address, it will get the one that is reserved for my phone's MAC address. Okay, so that's called a reservation. That's a setting that you can configure on a DHCP server within an IP address scope. You also have exclusions. This would be chunks of addresses within the range that you do not hand out. They're excluded from the list. Okay. So there's that. Oh, I did fix it. So it did have it listed as port 69. It's actually port 68. DHCP uses UDP port 68. Actually, let me confirm that really quickly. Yeah, I'm pretty sure it's port 68. Yeah, it is port 68. So you need to remember DHCP. In my original PowerPoint, I had it as 69 because of a typo in the PowerPoint. But the actual port number that's used by DHCP on the server end is port 68. So DHCP runs in the background on a DHCP server. It's a service on a server. There's a client service and a server service, right? And they both will run. The client service will request, the server service will reply. But the server service is listening for DHCP requests on port 68, UDP port 68. And if an IP address is requested, it looks at its IP address scope and sends a reply. Okay. So after an address is leased, a record is stored in a database. Okay, with a lease expiration time. This is stored both on the client end and on the server end. Okay, so the client is keeping track at the same rate that the server is keeping track. So this is actually measured in seconds, right? So it's a countdown clock, essentially, that says when the lease was assigned and how long it's good for. So when a response comes in, it'll tell this was assigned at this time, it's good until this time. Okay. So when 50% of the lease time has been elapsed, the computer attempts to renew the lease from the same DHCP server that originally responded. So it's going to go, hey, you originally gave me a DHCP address. Is there any way I could get a new one? The server says, sure, great. So then it's done, right? And it waits again until 50% of the time has passed. If there is no response, the computer waits until 87.5% of the time has expired and then broadcasts a renewal request. So it sends it to the entire LAN and says, is there a DHCP server somewhere out there? Here's a broadcast frame for everybody. Everybody's going to receive it, and everybody's going to look at it and say, not me, not me, not me, so on and so forth. Okay, if no response, when the lease expires, the computer will send another DHCP broadcast. So it sends it at 87.5%, and it sends it when it's totally expired. Okay, and again, if no IP address, if no DHCP server responds at all, then it does what's known as an ePIPA, which we'll talk about in Chapter 6. Okay, so here you see a screenshot of Windows Server 2016. This is the DHCP role that's been added to this server. You see you've got your scope, right, with a pool that shows IP addresses 192.168.1.1 to 192.168.1.100. That's your range. And then address leases. This is going to show a list of all of the computers that have leased an address with their MAC address and the IP address that's been assigned, and it's going to show the lease timeout. So it's going to show a clock counting down. And then you have a list of the reservations that have been added. So this is the MAC addresses that have been assigned a specific DHCP address. You see scope options. Again, that's going to have a lot of information. Default gateway and DNS servers are the most important. And that's that. So benefits of using DHCP. You can move a computer from one network to another and have no problem. And that's one of the biggest benefits. It also makes it so that you don't have to know anything about a network's configuration to connect to it. you can just join a wireless network, like for instance on your smartphone or on your laptop or whatever, and not have to know anything about networking. You just have to know how to click on the right name and punch in a password, right? And so most people are capable of that much, but without DHCP, they'd have to know quite a bit about networking in order to figure out what IP address to give their computer so that it could communicate on this network. So DHCP makes that a simple task. You don't have to do that anymore. So in fact, I don't think there was really, I guess there were days where you had to go manually assign IP addresses to every device before DHCP was invented, but those days are long gone. My entire career and even before, there's always been DHCP. Okay, DHCP servers are usually located on the same network, and DHCP messages are short. So DHCP uses UDP. When we talk about the transport layer, you'll understand. I'll delve into the difference between TCP and UDP. Those are the transport layer protocols. We're going to really delve into the differences and why they're utilized, but let's just put it this way. DHCP servers are located on the same network, and DHCP messages are short. That's all you need to know for now. If there's a DHCP server on another network, it's going to have issues with connectivity because DHCP messages initially are sent out when a client requests a DHCP address. It sends it out as a broadcast, okay? And broadcasts stop at a router, right? So do networks. So that's kind of a problem if your DHCP server is on another network. So typically they're located on the same network. Okay. So this is the process by which DHCP addresses are assigned, and I promise we're almost done with the application layer. But DHCP packets are sent in this order: DHCP discovered, DHCP offered, DHCP request, DHCP ACK. So the client initially initiates a DHCP discover packet. There's going to be a broadcast frame. It's going to go to all devices on the network because it doesn't have an IP address yet, so it can't, and it doesn't know where anything is at this point. It's just sending it out saying, hey, is there a DHCP server out there on my network? That's what it's attempting to do. So that's what that DHCP discover is all about. It's saying, hey, I'm looking for a DHCP server. And then a DHCP server that's on that network, hopefully only one. If you have more than one, you have problems. That's known as a rogue DHCP. That's not good. But if there is a DHCP server on the network and it's handing out IP addresses, it's listening on port 68, UDP port 68. It says, hey, DHCP offer. I'm a DHCP server. Here's some information. Here's a lease for you. If you'd like an address, here it is. Okay. So then the computer says, oh, sure, I would love this address. Can you please begin the countdown? I'm going to take the IP address. That would be a DHCP request. The client says, yep, I'm good with this info. I'll take it. And a DHCP ACK is sent by the server to say, hey, go ahead and start the countdown on your lease. This acknowledges the transaction between the client, and the client can now start using that IP address. Puts that into its settings, and now communication is possible. Okay, it's very, very handy. It's super convenient. It's super slick. We're going to look at this in the labs on Thursday, so come ready for that, and it should be good. Okay, so DHCP client is a service that's running on client computers typically, right? Servers don't typically run DHCP client software. There are some instances where that would be the case, but typically this is running on a client operating system. You can look at the DHCP client service in Windows. You can also make changes using the net command. I'm not going to delve into that too much, but here's what it looks like when you actually go to the services snap in and look at DHCP client service properties. So you don't need to dig too deeply into this. You just need to know that this is the software that's what's actually doing the requesting. It's the service that's requesting a DHCP address. So if this is turned off, your computer's not going to get a DHCP address. Okay, I'm going to stop there for now because this one's over 30 minutes now, and I'll do DNS in the next one. DNS is kind of long-winded as well, so I probably should have broken up DNS and DHCP into their own. But anyways, I'm going to stop here. I'll upload this, and we'll get started on DNS in the next video.